Hi, everyone. Thanks for joining us today. And the topic that we are going to talk about is why the option pattern is great for security. And this is the last talk of this conference. Like, we're almost at the end of the hour. So I will just give it over to Dima, who is an application security engineer, but I'll let him speak more about him. So over to you, Dima. The stage is all yours.
Thank you so much. Thank you for this opportunity to speak. My name is Dima Kotik. Today we have a subject, why the options pattern is great for security. A small idea that will make a big difference. A little bit about me. I'm an application security engineer. I work at Security Journey. We provide training by developers for developers in all things related to security. I'm obsessed with service reliability, and I'm excited about Golang. So incidentally, the examples in this application, in this presentation, will be in Golang because they fit nicely on the slide and because I like it. We have 4 goals for this presentation. First is we're going to review the options pattern for complex object initialization. Second, we're going to discover the types of vulnerabilities it can help prevent. Third, we will try to improve the classic paradigm to maximize security, and I think we can do this very well. And fourth, we will try to inspire developers. I hope my talk inspires you to adopt the pattern when it fits in your next version release. So let's start with the problem. We have the OWASP top 10, number 6, security misconfiguration. This is very common, of course, has everything to do that touches the cloud. It is very easy to misconfigure the cloud because it's remote and not very well observed. But also it affects applications. There's a million ways to misconfigure an application and make it insecure by mistake. But there is something else about this issue, is that it's number 6. That's pretty high on the top 10. But also, there are not too many things that we can do about it as of now. There are basically 2 kinds of advice that are floating out there. First is stop misconfiguring your services. Well, we can try. And the second is use a tool, a scanning tool that can detect vulnerabilities. They can verify configuration. Well, the problem with this one is that, of course, the tool has to encounter a problem first. It has to discover a weak configuration somewhere to detect it. So neither of those 2 are going to really help us much. So the question is, what can we do besides just those 2 things? And just to bring this down to the practical level, okay, attackers, they love certain things like candy because certain types of attacks are just easier for them because, for example, of a hamstrung cipher, and that can be related directly to configuration. There can be an insecure source of crypto, and this can come from just poor configuration file or implementation detail, or it can come from a legacy algorithm that was configured and should have never been used, or it can come because of a short key length. That happens, and your program can have all the capability to defend itself, but because of misconfiguration, it messes up. A missing access control, this happens, or a misconfigured access control, where something was supposed to be hidden or prohibited, and it was turned out to be allowed in production. And of course, debug backdoors. We need low-level access. We need powerful access to our applications to debug them, and how many of them are spinning in production with debug backdoors enabled. That happens, and sometimes you do it by mistake, but sometimes it's just what happens. And attackers just love those things, right? Because this is just candy for them. And it makes their life so much easier. And we shouldn't be making life easier for attackers. So the question is, can we do anything on the engineering side? Can we make our applications resilient to misconfiguration at the very core? And the answer is, yes, we can. Enter the options pattern. So what is the options pattern? Maybe you have heard something, maybe you have heard nothing. So let me just give a definition. It's a flexible object provisioning strategy using a list of independent object modifiers. So what you do is you have your package, your engine that you're going to do stuff with, and what you're going to do is apply different modifiers to it, a list of modifiers. Those are usually functions, and each one will narrowly configure one part of our engine, and then we'll put it into production. And if everything went well, that engine should be running secure and great. Well, of course, to get deep into this, let's first review a classic approach. And before we even get started with that, let's look at the builder pattern. That's very familiar to all the Java programmers, anyone who's in the object-oriented world. Very simple. We want a bank account, and we're going to use one object to construct another. And we're passing different arguments to methods of the constructor object that we would like to have, the different traits and parameters we'd like to have in our bank account. And finally, we call build. This is the classical builder pattern. Well, the options pattern is kind of like an odd cousin to the builder pattern. And superficially, they look the same, but there are some very significant differences. And the option pattern is definitely better for security. But let's look at how this functions, right? So instead of an object configuring object, the option pattern is a list of functions that will configure our object. And we pass that list of functions to our constructor. So in this case, number 2 is the new bank account constructor. And it will take narrow modifications that will be applied to our bank account. Again, superficially, it looks exactly the same, just slightly different in syntax. But under the hood, the difference is great. This is how I first learned the options pattern in the Go community. And it took me a while to see the value of it. So this is just a classic definition. You define an option, a type, and we'll call that type an option. And this option will take a function which will modify something. In this case, our engine is just a bank account for simplicity. So an option will take a pointer and will do something to that bank account. Well, let's write one option at number 2. Let's write a function, and it will be a closure that will return an option. It will take a parameter, email, and it will attach this email to our bank account. And so it will return the option, right, which will be a function that will touch our bank account and will insert that email right into the appropriate field, client email. In Golang, lowercase parameters are private. So this is a private field. And of course, that's very important. We don't want people touching our parameters apart from options. So only options should be modifying those. Those should be safely protected from, again, misconfiguration. So nobody goes and starts changing our object without going through the proper routine. So that's the classic. Can we do anything to improve this classic? Can we do anything better with that, with security? Oh, yes, we can. So the key here is a secure coding practice of failure, correct kinds of failure. And there's 4 components to this. We want to fail early as possible, and object initialization is about as early as you can fail. We want to fail safely, so our program just doesn't crash, our application doesn't just disintegrate, but just can handle the error, or the caller can handle the error graciously. It needs to fail explicitly so we know what the cause is, and there is a way to figure out what went wrong, and singularly, right? We don't want to have a cascade of failures, like 5 or 6 failures at the same time when you don't know which one really fired it. And the reality is, if you're really serious about security and you're following those fail practices, insecurely configured services should never even start. That's what it means to have security on by default. And we have that as an ideal, but we don't really get it too much in the wild out there. And we can with the options pattern. So let's improve this classical options pattern. And this will be a very small change. It's very subtle, but it's actually very significant. In our option type, we declare the function that modifies our bank account. We will add a return type of error. So now our option modifies and returns an error. In Go, we return errors. Of course, if you're writing in another language like Java, it's still kind of considered standard to throw errors. Sure, but the idea is this. Move your validation code out of your constructor into the option. The option should do all the parameter validation narrowly and should handle it inside the option, not in the constructor. And you'll see how big of a difference this makes later. So now we can modify our little simple option with email. We're still taking the parameter and returning a closure option. But this time, we will have a little validation routine at the very top, and we'll just check, is this email valid? And if it's not, we'll throw an error. And the rest is the same, except if there was no error, we'll return a no. That's a small improvement. OK, let's look at our constructor. What would that look like? We will take a constructor and call it new bank account, and it will take a list of options. And it will apply each of those options successively to our bank account and return the bank account and an error. Let's start with an empty bank account with nothing in it, and then we will iterate through every option in the list and apply the option to our resulting bank account that we will return. And if there is an error, we're going to interrupt execution at the first error. We don't want to, again, cascade and just fall over. We want to fail early. And then we also should wrap the error so it's clear that this is initialization failure. So this is easy to diagnose and handle upstream. Then at the end of our constructor, we will validate the result, but not the parameters. Remember, the parameters are to be validated in the option. And we'll simply check if mandatory parameters were set and maybe do some other checks and then return our result. So that's pretty basic, looks like a little bit of boilerplate, not too bad. And what does this help with? Okay, it help us fight against three things. First of all, invalid or insecure state. Right, so nothing should be nil, nothing should be missing or misconfigured. If something is wrong, it should be detected at initialization. And wrong configuration or weak configuration is also a failure state. We should detect that, and the option pattern can help with that. Second is failures originating in parameters. Okay, our objects can be pretty sophisticated, and some parameters pass behaviors. That's pretty significant. Do you trust that behavior? Do you know that it actually works? Where it was configured? Who configured it? You don't know. So it makes sense actually to do a little bit of checking just to make sure that it doesn't just satisfy interface, but it's actually there and it's alive before you're going to run with it. And the third, of course, conflicting parameters. You have situations when one parameter can cancel, undermine, or disrupt another parameter, and that would be really bad. So we can use the options pattern to prevent that. Usage criteria, when do we really want to use this? Not all the time. It's great, but it's not great for everything. So typically you will use this one per package, and the package has to be sufficiently sophisticated. So those three criteria will really help you. First of all, flexible behavior. You're using providers, drivers, caches, something that will change the way your object behaves depending on the situation. That's flexible behavior. That's great for option pattern. Second, if you have some mandatory parameters but not others. If all of them are mandatory, you may be better off with a more straightforward API that's easier to follow. But if some of them are mandatory, some are not, that's complicated, and they could be affecting each other, so options pattern. And lastly, entangled parameters. Again, entangled parameters is that when you change one, it creates a side effect for another. And you have to keep checking those. So with a builder pattern or a factory pattern, what you end up doing lots of the time is just writing multiple builders and multiple factories. And then that's just extra code. It's not singular. It's more things to test, etc. With the options pattern, you can deal with entangled parameters very, very well. Let me give you an example how to do that. Okay, so let's suppose we have an IoT device and we're writing a hypothetical asset encoder. I'm going to do some encoding and in turn, return an error. So let's start with an option called with block size and memory limit. And we'll put size and limit together in the same option. Why do those go together in the same option? Because they're entangled. They have a relationship between them, a logical connection that can't be obscured. So I can think of, from the top of my head, just three things immediately that will affect this, right? So if you have a block size and a memory limit, first of all, the limit has to be greater than 0 and greater than size, and size has to be greater than 0. Second, the limit has to be a multiple of the size, right? Because why would you create a buffer that would not fit eventually one of the blocks? That would make problems. And third, of course, you may know from your encoder, it's an IoT device, so it has only 2 bytes reserved for block sequence in the tag when it's going to do our encoding. So you may have only a certain number of possible blocks, and that will create a limit, another constraint on your limit. And so I don't know how the logic is going to work, but immediately I'm noticing I have to deal with those three things. Okay, in Go, that's benign. Those will probably give you like some glitches, and maybe one of them will be a vulnerability. But in lower level languages, each one of those is potentially buffer overflow. And that's bad news. Okay, we're talking about DOS, crashes, remote code execution, all sorts of terrible things that can happen to you just because the conditions were not dealt. And notice they are entangled. So if you have a setter setting size, you got to check that the limit is still legit, and the other way around. How do you do that without duplicating the code? All right, here we go. An option that takes both of them, checks both of them singularly, assigns both of them, and returns a nil if there was no error. That's really good, right? And the other thing about this, okay, let's talk about security and clarity, right? When someone else is using your API, someone else is using your object, they will be able to tell that those two parameters are related. This is what we call self-documenting code. So when the person starts typing all the options out with the help of the IDE, they'll see, okay, with block size and memory limit. They may not know how they're related, how they're connected, but just by the API themselves, they can tell. And that's safe because, again, it helps the user, the consumer of your object, not to misconfigure it by mistake. And of course, if you wrote all your conditions correctly, you're already checking for that anyway. So are we done yet? No, there's more improvements. Another one is called option grouping. And this is really great. This can help us with isolation, clarity, and safety by doing a few little small tricks. And seriously, when I first saw pieces of this code that I later worked to improve, I didn't understand. It took me like a year to figure this out, the value of this, and it's really good stuff. We have a little helper, which is called with options. And with options, we'll take a list of options and make it into one option. How? By iterating one by one through each options and applying it to our object and checking for error. Wait, we have already done this in the constructor. Why would we pull it out into a helper function? Just a second, I will explain. But first of all, since we already ripped that code out, let's change our constructor. You can see at the bottom of the page. And let's replace that whole loop with our little helper, with options, and give it a list of options, and then wrap the whole thing with initialization failure if there was one. So what does this little helper do? What kind of difference does it make? Well, if we really unleash it, it makes so many different powerful things. First of all, those are just examples. You can think of more. You can make option sets. And the best one is, of course, with default options. How convenient is it when you're dealing with a complex object to just click and see all the configuration settings that go with it by default without having to read every single setter or all those different factories and checking for all the different checkers, right? Just one click and you can see right away what all the defaults are and what you might want to change. Very convenient. Second, you can have a set that's called with debug options. And that's exactly for debugging, right? And so you can use private options inside this option group that would not be accessible otherwise, because debugging options may not be safe, and you don't want to be people, mucking with them and loading them and applying them to your object in production. So you just protect them by making them private and then make them available through an option set. And by the way, while you're at it, why don't you just add a little check that will check if the instance is in production? Because if it is, well, let's crash it, right? We don't want any backdoors running on our production instances. And third, of course, visual grouping. Sometimes you don't have entangled parameters, but for clarity, you may want to put them on the same line and add a comment to a group of options. Sure, so all you do is just use our helper with options first, second, and third, add a comment, and that's very convenient visually. You can nest as deep as you want. You can do whatever you want. It's just really, really flexible. And your constructor will not know any differently because, from his perspective or her perspective, our constructor will just iterate through all the options eventually and move on to do great things. So this is incredibly powerful. Let's put all this together. We talked about very, very basic, simple examples. But to really see where this shines, we really need something more complicated. How about this? Sufficiently complex object. Hypothetical distributed secrets manager. Is that sophisticated enough? Oh, yeah. So let's start writing this, and we'll use the options pattern. And of course, if it's distributed, we'll need some peers, maybe a peer discovery protocol, maybe both. Why not? Let's just stick it in there. If we don't end up using it, we can always delete it. Caching layer is very good for performance. So let's use a Redis caching instance, and we have our adapter that will work with our secrets manager. And that will give us performance that will be great. And then, of course, if we're going to do some basic cipher calculations without revealing the keys, we will want to have a list of allowed ciphers. Sure, let's do that. Our keys will need to be rotated. So let's specify rotation window and max key lifetime. Wait a second. Rotation window, max key lifetime. Those are pretzeled. Those are entangled parameters, right? They have a relationship between them. So max key lifetime, cannot be less than the rotation window, because then the services will become unusable. But also, they can't be too long than the rotation window. If it goes through like 5 rotation windows, the keys like really hang out there for a long time. And the whole point of a secrets manager is to rotate the keys. So we got to deal with that. Those two are related. So how are we going to deal with that? Well, I just showed you an example of dealing with entangled parameters by grouping them in the same option. Would that work? Let's try. So with rotation window and max key lifetime, is that smart? That's really wordy and really weird. And then you start thinking, okay, but what if there are more parameters that will affect this? Then what, do we just keep growing the option and then it turns into like this mega option? That's no good. But then the other thing is that what if somebody or something misconfigured the cache and validation, or just misconfigured our cache in such a way that things don't expire on time, or don't expire at all, just hang out there for eternity. And then you have broken access control, ghost keys that are just hanging out in your cache that should be long expired, but because of the cache configuration, it's just hanging out there and just waiting for an attacker to sweep them up and use them. And you realize, okay, you don't have just 2 parameters pretzeled. You have at least 3 things here pretzeled, and then maybe more. How would you go about fixing that? Well, we have a flexibility, and in this instance, we can just hybridize 2 different approaches and switch to keyword initialization in this case, because we expect that there may be more parameters. So let's just write an option that will take a list of keywords, a structure, without parameters, and we can just leave a comment there expecting there could be more in the future. But also, since this is a structure used by one option, we can share it internally in our object with our cache settings and synchronize the 2. So now you see, you can make it in such a way that there's no way to misconfigure it. Because if somebody starts messing with your cache settings and giving you incorrect invalidation keys or something, or tags, you can detect that with the other option because you're sharing information between the 2. The point here really is that the pattern, helps you think. Helps you think and helps you anticipate those problems, misconfiguration problems. We can even call this pattern like option-driven design and write a book about it. Maybe. I'm just kidding. Yeah, that would not be fun. Let's go to another service, hypothetical microservice. That would be great, right? With host and port, those 2 are related, entangled. Let's put them together into one. We'll need TLS. That's great. And then also we'll need timeouts. Timeouts are really important, right, for microservice, because it's going to be communicating with other microservices, and it's probably something we want to share. So in this case, let's not even use a list. Let's use a structure called timeout settings, and we'll have ingress, egress, and idle session. And those settings can be shared with just about almost any situation you can imagine, and you can add maybe another one if you need to, and use one option to configure or interact with several different things, right? Of course, we keep going, and we'll have a secrets manager, because hypothetical service microservice will need one. Obviously, let's use a KMS adapter to export that behavior out. We'll need a throttling strategy. That would be bad if our microservice wouldn't throttle, because then it's sensitive to DOS. And we can have a set of different strategies and pick one, like throttle by IP. That will work for now. Retry strategy, sure, 2 times immediately. Sounds reasonable, and we can swap it out later if we need to. And of course, we'll need a way to manage state, and Redis is great, so let's go along with that. And logger, right? Logging is a whole other area and a whole other subject. Do you want to stick loggers everywhere? At low level, probably not, because that's a side effect, and that creates difficult to test things. But on a high level complex object like this, logger is definitely a good place to put it, right? So you may want to write an interface and satisfy that interface with a logger of your choice, or maybe even multiple loggers. This is just an example, and you can already see, where this is going, right? So it's helping us design, and it's helping us put all those different pieces, each of which can be complicated, into our object and configure it safely, because you're going to be checking every single piece of this independently in your options. Okay, how about a hypothetical encrypted network tunnel? Of course, we want some flexibility for the packet size, because who knows what is going to be running on, what kind of hardware it will have. Sometimes you need large packets, and sometimes small packets are good for quicker turnaround. So let's make that configurable. Since it's encrypted, we'll need a key provider. And of course, since we want our tunnel to be stable, we'll need a recovery fallback. And we'll have a fallback strategy using a journal. What if something disconnects, or our server crashes and it needs to come back from the dead? Well, the recovery strategy will help. Of course, a nonce factory, and we need a way to synchronize the nonces, right, between different parts of the tunnel, or otherwise they will not work. So that's an external behavior that will need an option. And an error handler. Error handlers are great, especially configurable ones. And this is an example of using a closure. Passing a closure to an option, oh, that's great. Very convenient, especially maybe you don't need something that's complicated. Like here, you maybe just want to test for some error or watch for some error, and you just want to add one error handler, maybe 2. Well, that's convenient. And you can see, this is very, very flexible, but also there's an elephant in the room that I did not even mention. Okay, look at the examples carefully. Just think back in the memory, okay, what we're doing. we're pulling out sophisticated code away from our object, out of our constructor, into an independent function. That's the most testable object initialization strategy that you are ever going to get. Because each option narrowly modifies our object in just 1 or 2 parameters, maybe 3, you test that option. And of course, you can test the whole constructor as well, but you have a way to singularly isolate problems and group them by behaviors and put them into automated tests. No more writing multiple builders, multiple factories, and then testing all of that, all that other stuff. This approach is extremely, extremely good for automated testing. And of course, we know with security, testing is really good. So the easier it is to test, the more you can test, the earlier you can test, the better off you are. And the option pattern serves this. OWASP top 10, number 6, security misconfiguration. Do not trust configuration. If your application falls because of misconfiguration, it may not be the problem with configuration. It may be a problem with the application. Security by default means that bad configuration should be rejected, should be detected, right? And if we apply this approach, or maybe more rigorous other approaches as well, I'm sure there are other possibilities here. But this in particular, we're definitely, I believe, can cut down this from top 6 to top 12, maybe within a year or 2, hopefully. I think we can do this. Options pattern is great. So let's sum up what we learned today. First, if something can be misused, it will be misused. That's just a matter of time, right? It's just team dynamics and the complexity that we're dealing with. Cloud, right? Anything that goes to the cloud, if it can't be misused, it will be misused. It will just fall over one time. So to be secure by default means that weakened services should not even start. Those parameters need to be validated and failed right away. It's not good to launch a weakened service. It's much better that it falls over because you're not then exposing your customers, you're not exposing your data to attackers. Crash it if there's a problem. Second, the option pattern guards against misconfiguration, OWASP top 10, number 6, right? Invalid initialization states and other vulnerabilities, depending on the situation you're dealing with. You can test and check for almost anything. So you can include a wide gamut of problems that could be solved just by using the appropriate pattern. Third, the options pattern is convenient for automated testing. That's a talk in itself, but I hope you got the point just from the examples. And the fourth one, implement the options pattern in your next major version release to bolster security with a boost of code readability, reliability, and resilience. I hope I can inspire you. I hope I can inspire you to just take this, try this, see where it takes you, and see if the next release version of your library, of your application, just all of a sudden does a whole lot better and is easier to work with for your entire team. By the way, there's a QR code on this slide. So if you scan that, you will see a full compilable Go example with comments, with more details than we could talk about in this presentation. And also there's my Twitter handle. If you have questions, suggestions, or if I made mistakes, please write to me. Thank you so much for this opportunity.
Thank you so much, Dima, for sharing the wonderful insights. It was a great presentation. Everyone enjoyed it. I don't see any questions at the moment in the chat box, but I'm sure people would reach out to you over this, your Twitter handle or any other information that you want to share.
Thank you so much.
Yeah, thank you so much for joining us today. It was wonderful to have you. Yeah, thank you so much, everyone, for joining us. This was the last session of the day. We'll see you in the closing remarks. And before you go, we would like to say thanks to our sponsor, SNE, for providing us the resources and everything. Thank you. And see you all soon at the closing remarks.